All right, everyone, welcome to section 10.2. We're talking about rational exponents today. So let's get started. We got quite a bit to go through. So we're going to, a couple of different objectives today. We're going to use rational numbers as exponents, and then we're going to apply properties of rational exponents. So the first of basically three main rules of exponents. So I'm going to call this rule one. Of exponents. Okay. The first one says that basically if I have a number and the root here is a fraction, I can put that in radical form by putting the denominator of the fraction as the root of the radical, and then the other number a on the inside here, if I'm using a and n, and then this would be like a to the first, but I'm not going to write a 1 there. So that's basically how that works. Okay, so if I had something like 25 to the 1/2 power, that's the same thing as really the square root of 25. Generally we don't put the 2 there, but just to emphasize the idea, and then we also don't put the 1, but that's kind of what this is, right? So this would also be known as, or the square root of 25. So those two things, the square root of 25 and 25 to the 1/2 power, mean the same exact thing. Let's do some examples. Write each expression in radical notation, then evaluate the expression and round to the nearest hundredth when appropriate. So let's do this one, 49 and a half. Let's see, did I put room on there for all those? I think I did. I'll get to that in a second. So 49 and a half. So what is this? Or 49, not and a half, 49 raised to the 1/2. So basically what this is I can rewrite this again as the square root of 49. Those things mean the same thing. And then we'd all know that the square root of 49 is equal to 7. Now 26 to the 1/5, and again, you should be able to type this into your calculator, and I'm not going to show you how to do that, but if you can't, just let me know. 26 to the 1/5 is actually going to give you a decimal number. So if you do that, trying to get my calculator right here. There we go. I had it on a weird setting. 26 to the 1/5 is going to give you a decimal. So it's not a whole number. It'll be about 1.9186. And again, in this case, they want us to round to the hundredth. So the hundredth place is right here. And again, we always look 1 to the right there, in this case at the 8. So this is really going to be 1.92. And then the last example, there is 6x raised to the 1/2 power. And again, I can rewrite that in radical form and just the square root of, whoops, I was writing, 64, not 6x. Here we go, square root of 6x. So that's how you rewrite that. All right, this is going to be rule 2 of exponents. Okay, so our main rule number 2 here is if m and n are positive integers with m over n in lowest terms, then I can rewrite it as follows. And this is basically the same rule as that we just had, but a couple of different things. So again, I can rewrite this a to the m over n as root n of a to the m. And then I could also write that with parentheses, basically putting this part, the root n of a on the inside of the parentheses, and then the m on the outside. So those are all three of these mean the same exact thing. I can switch and kind of interchange them. And again, same thing with last section 10.1. If a is less than 0 and n is an even integer, so we have an even power, then a raised to the mn is not a real number. So again, same rules apply. Basically, if a is less than 0, then n would have to be odd, but if it's even, it's not real. All right, write each expression in radical notation, evaluate the expression by hand when possible. So let's kind of demonstrate some of these using that last rule for exponents. So if I have -8 raised to the 2/3, again, I can kind of rewrite that using that rule. So I can say that this is the cube root of -8 squared. So I can use the parentheses one, right? So your denominator of your fraction becomes your power of the radical, okay? And then I can bring the 2 on the outside there. So then I can continue and keep simplifying this. So the cube root of -8, I can do that because I have a negative with an odd power there. Cube root of -8 is -2. And then put the squared in there from right there. -2 squared, -2 times -2 is 4. And then this one, 10 raised to the 3/4. Again, if it helps you, if you want to write it like this, or if you want to keep it in this form, that's fine. But again, really, they all mean the same thing. You can take this 4, put it right there, and then this is 10 to the 3rd, which we know 10 to the 3rd is 1,000. Now, if you tried to put this into your calculator, you would get a decimal. This is not a whole number. You could take the 3rd root of 1,000, which would be 10, but I can't do the 4th root, okay? This would be about 5.6, okay? But I really want to, I only want to evaluate it if it's possible, okay, to do it by hand or really to get a whole number. All right, let's do a couple more examples. So I have 81 to the 3/4. Again, I could rewrite this as root 4 of 81. Oops, that is a bad 4. Sometimes my writing pen here sticks a little bit. Let's try that again. 4, root 4 of 81, and then raised to the 3rd. And I know that root 4 of 81 is actually 3. And then 3 to the 3rd is 27. So that's how you do that. And then 14 raised to the 4/5. Again, this one doesn't look like it's going to come out nice for us. So we can basically just only go as far as possible. So this could be the 5th root of 14 raised to the 4th. And that's really as far as we can go, okay? So this is not a whole number if you typed it into your calculator, so we can't evaluate it by hand. So that's, this is really your answer. That's as far as it can go. Just a couple of calculator notes if you're using your calculator. So when you're putting in, let's say it's 8 raised to the 2/3, make sure that you know, when you push the little kind of roof of a house, I call it the hat button. When you push the hat button, make sure that you put your power in parentheses, okay? So 8 raised to the 2/3 in parentheses. If you don't put the parentheses around the 2/3, basically what it's doing is it's taking 8 raised to the 2nd, which is 64, and then dividing it by 3, okay? So this is the correct way. Use parentheses when all else fails. I just always use parentheses for this kind of stuff because it just, you know, eliminates the possibility that the calculator is going to read it just some other way that you don't want it read. And then this is rule 3 of exponents. So kind of our last main rule. We're going to have actually a whole bunch of other rules coming up here in a little while. But these are your main 3 rules. If m and n are positive integers with m over n in lowest terms, then a raised to the negative m over n is equal to 1 over a to the positive m over n. So what you can do is you can take this, this negative fraction and you can put it in the denominator, but making sure that you carry the a with it, okay, and then write it as 1 over. And again, a cannot be equal to 0, because if it was, then I would have 1 over 0 raised to the something, which would just be 1 over 0, which is undefined, right? So we can't have that. So these are the three main rules that we just covered. I'm going to do some examples here, specifically with rule number 3 next. So I have some negative exponents again. So what we do, so 81 to the negative 1/4. So what I can do there is I can, well, let me just rewrite it as 81 to the negative 1/4 if you like it looking that way. Again, this negative, it's kind of even with the fraction bar. It can really be in the top or the bottom. I just always put it even, okay? So don't really assign the negative to either one. Just put it even with the fraction bar. That's a good general rule to follow. And then what I can do again is I can write this whole thing as 1 over this entire thing, and that makes the exponents positive. Okay, or the exponent positive, because you'll have some answers where it'll say write the answer with positive exponents only. This is where that kind of comes into play. And then from here, what you can do is you can write the 81 to the 1/4 power in radical form. So the 4th root of 81. And we know the 4th root of 81 is 3. So this would end up being 1/3 again. And kind of a quick note here, okay, and I'll kind of star this, is you can use your calculator to check, okay? So you can use your calculator to check these, okay? But on a test, okay, on a test, I need to see the work. I need to see the steps, okay? So just make sure you know how to do the steps. Anyone can just, type in 81 to the negative 1/4 in their calculator and get 1/3, okay? But I want to see these steps, how you got it, okay? Because it's really the process that counts. So when you, for those of you who are going to have to take pre-calculus and then eventually on to calculus, you're going to need to know some of these things, some of these steps. And it's just a good habit to know how to do instead of relying on your calculator. So let's do B, 64 raised to the negative 2/3. So again, if it helps to write it out like so, you can. And then make this with positive exponents. So put it as 1 over 64 to the 2/3. Write the 64 and 2/3 in radical form, okay? And then simplify it. So do this, do the parentheses first. So the cube root of 64 is 4, and then 4 squared is 16. So this is going to be 1 over 16. Again, if I'm going too fast, slow it down, okay? Rewatch and try it again. All right, some more examples. So I really want to do a bunch of examples for these. That's really the only way to learn it. We're going to have more rules of exponents here, I think, on the next slide coming up. And again, the only way to really do this is by going through examples and making mistakes if that happens. So the 7th root of x to the 3rd. So again, I can take this and I can make this into a fraction form. So I want to write these as radical expressions instead of using the radicals. So this is actually just going to be x to the 3/7. It's that simple. So I can basically use rule number, let's see what I got to look back, but that would be rule 2, basically, to do that. This one, I can rewrite this as 1 over b to the 3/2. And then, actually, do I want to do that first? Yeah, I do. Because remember, this is a square root, so really this is a 2. So this is 3/2. And then if I want to, I can write this, I can move this actually up. So kind of going the opposite of rule number 3 that we just learned. So b to the negative 3/2. So I want to write these as a radical expression, a single radical expression. So having the 1 over, that would be kind of a in rational form. Okay, so it'd be in kind of like a fraction form. I want to change that to not have any fractions, at least. I mean, I can have fractions obviously in the power, but not in the problem itself. So let's take this next one. Again, all I'm doing here is using, this would be rule number 2 that we just learned. So I'm just taking this guy, and then I'm raising it to the 2/5. Okay, so this root here goes in your denominator, and this power here goes in the numerator. And same thing with this one. I put the entire expression a squared minus b squared in parentheses. And then this whole thing would be to the power of 1. And then again, the 4 is on the outside, so that goes in your denominator of our fraction. So let me just circle these. Those are all of your answers for those. So just a few examples there. Now, I'm going to get into some properties of exponents. So quite a few different things here. You really have to pay attention to this. So this is a lot. Okay, be careful with these rules. I would really highly suggest you write them down so you can refer back to them later. So I have names for these, and there are proper names. Sometimes I'm going to use those, sometimes I'm not. I might just say, like, for rule 1 here, if I'm multiplying exponents with the same base, I add the exponents. Okay, so I add the p and the q here. If I'm multiplying an exponent with a base of a and a negative exponent, again, I can put that as 1 over the base with a positive exponent. That was kind of the rule that we did before, rule number 3. This one is if I have a fraction with a negative or raised to a negative exponent, I can make that negative exponent positive, but then flip the fraction. So basically, this one, I could distribute this negative one, and we'll kind of see that down here. I could use the power rule, but I could say that this is a to the negative p. So I can basically distribute this negative power to each a and the b. A to the negative p over b to the negative p, and then flip-flop these. So b to the p over a to the p, which again is a over b, or sorry, b over a raised to the p power. This is the quotient rule. So if I have two exponents or two expressions of the same base, and I'm dividing, I subtract the exponents. Okay. So I can take this as a to the p minus q. That's the quotient rule. And then this I can distribute. So this is the power rule. I kind of did that over here. So a raised to the p times q. So I can distribute the p into here, kind of like multiplication. And then this one is, again, another power rule for products. So if I have a product on the inside of here, I can distribute the p to both a and the b. So it'd be a to the p, b to the p. And then this one, there's a power rule for quotients as well. And I kind of did that up here in 3 to make sure that you know how to get this guy. Okay. But it's the same thing. I can distribute this exponent to both the a and the b. All right, let's do some examples. So write each expression using rational exponents and then simplify. Okay, we want the answers to have a positive exponent. Okay, and for this, just to eliminate absolute values or anything like that, we just assume that all the variables are positive numbers. Okay, and just to also eliminate different cases where it might not work, right? Where we might not have an actual real number answer. So let's do some of these. So if I have the square root of x times the fourth root of x, I can rewrite this as x to the 1/2, right? Using using one of our rules. And then this one would be x to the 1/4. And you can look back at what rule that was. I forget. I think that is, if I'm looking, that would be basically rule number 1 that we talked about way earlier. Okay. And then now, since I am multiplying with exponents and that have the same base of x, I can keep the base and then add the exponents. So I can add 1/2 plus 1/4. And that would give me 3/4. All right, same kind of thing here. So I think this is rule 2, where I have the 4 and as our kind of our power there, and then I have an x to the 3rd. But what I do here is I can say that this is 256. Wow, I did not write that. I wrote another 5. I can say that this is 256 x to the 3rd, and then this is all raised to the 1/4. Now, this is going to be rule or property, I should say. This is going to be property number 6. Okay, property number 6 to get to the next step here. So I'm going to distribute the 1/4 to the 256 and then to the x to the 3rd. Now, 3 times 1/4 is just simply 3/4, but I'm going to write it like this first, just so you know. 256 to the 1/4. Again, that would be like the 4th root of 256. That's the same thing as 4. And then now I can distribute the 1/4 to the 3. So I have x to the 3/4. And I really should rewrite these. The 4s are looking like 9s or something because keep dragging my pen here. There we go. Okay, so 4x to the 3/4. And I'm just going to keep going with examples because it really does help. And then I'll try and refer to what rule or what law they are. So I'm going to kind of keep looking back in my notes here. So this one, I have the 5th root of 32x. So again, what I can do there is I can write this as parenthesis 32x to the 1/5. And then this one I can write as just x to the 1/4. Okay, again, that would be, if you really need a law or rule, I think that's rule 2 that we covered earlier. Okay. Now with this, what you're going to do is you're going to simplify. Okay, so take the 1/5 and multiply it into the 32 and the x. So it's going to be 32 to the 1/5 power, x to the 1/5 power. So distribute it. And then 32 to the 1/5 power, again, that's like the 5th root of 32, which is 2. And I have x to the 1/5 over x to the 1/4. Now, I can take the x to the 1/5 and the x to the 1/4, and I can use our quotient rule, so I can subtract those up. So I can take rule number 4. Okay, again, I'm using property 4 to get to the next step here and subtracting these. So you actually are going to end up with a negative here. 1/5 minus 1/4 is actually negative 1/20. And then I cannot have negative exponents, so I'm actually not done. So we have to have these with positive exponents. So what I do is I take rule 2 here, and I put the x to the negative 1/20th on the bottom of a fraction. So this is going to be 2 over x to the 1/20th. Okay. Now, as you're doing some of your homework problems, I just want to make a quick comment. If you don't know what to do, if you get lost, click the view an example button. Okay. It'll go over a similar problem and it'll go through all the steps for you. So if your problems have that option and you're struggling a little bit with this, click on view an example. Maybe you've already figured that out. So let's do the next one. Okay, same instructions here, but this time I have this negative power outside of the parentheses. And what I can do is I can use property 3 here. Okay, look back, property 3, when you have negative exponents for quotients. So what I'm going to do on this one is I'm going to flip-flop the numerator and denominator, and then make this exponent positive. Okay, so make that into a positive 1/3. Now I'm going to use, let's see, what property is that? Property 7 to basically distribute that 1/3 in there. Okay. And then now I can simplify. So 27 to the 1/3, again, that's like saying the cube root of 27. And well, let me simplify the denominator here. So x to the 3rd raised to the 1/3, that's just going to be x. Okay. Because 3 times 1/3 is just 1, so it's x to the 1st. Remember, you're gonna distribute those in there, which is property 5. Okay, so this, if you need it, this is property 5 to get here, and then cube root of 27 is 3. So this one is not 3 over 3, but 3 over x. All right. That's another example. I think I have just a few more examples, and then we'll get you on to the next section here. So simplify the expression. This is a homework question. Okay, I don't know which number it was. I just kind of cut and pasted out, but I thought it was a good one to go through. So anyway, you're going to use your property 5 again to multiply those powers in there to your exponents. So basically what I'm doing is I'm taking the -2 and I'm timesing it by 1/6, and that's -2/6, which is -1/3. So this top part here is k to the -1/3, and then I would have k to the 5th times 1/3. 5 times 1/3 is simply 5/3. And now what I can do is I can use property, let's see, 4, which is the quotient rule, okay, to subtract, right? So I'm going to bring the 5/3 up by subtracting, okay? -1/3 minus 5/3, that's -6/3. I have a common denominator. I can just take -1 minus 5 is -6, so -6/3. And -6/3 is -2. And now I can't have negative exponents. So I'm going to bring this down into the denominator by using property 2. So it's 1 over k to the 2nd in this case. And again, your homework numbers might be a little bit different, but that's kind of how that works. Just a couple more questions. I didn't notice anything like this one on your homework, but I thought it's good. It's good for you to be able to do. So I have the 4th root of the square root of x plus 2. And what I do there is I basically work my way from the inside out. So I'm going to say this is x plus 2 to the 1/2 to the 1/4. And basically what I do is then I'm going to distribute the 1/4 into the 1/2. So I have x plus 2, 1/2 times 1/4 is 1/8. And then kind of a quick, simple one to finish up here. Y to the -1/4 raised to the, or sorry, y to the -1/4 over x to the -1/5. I need to make those exponents positive, and I do that by just flip-flopping them and making the exponent positive. So I have x to the 1/5 over over y to the 1/4. I think that's it. So let me stop the share. That is all for section 10.2. Again, there's a lot in this section, and there's kind of a lot in 10.1. So I just broke down these two sections into one homework assignment. So please let me know if you have any questions on any of this. Again, it's the only way to get good at this is using practice, using different examples. And just let me know if you need any help. So thanks for watching. We'll see you again for section 10.3.